Acid and bases are two particular types of compounds. Many substances we encounter each day can either be classified as an acid or a base. Acid includes edible acids such as citrus fruits and their citrus acid, vinegar, fermentation of fruit juices to make wine. While base includes soap and other household cleaning products and baking soda. Some acid and bases are safe to eat while others are deadly and highly corrosive. So let's talk about acids. An acid is a compound that produces hydrogen ions when dissolved in water. Some acids are safe to eat, as what I've said earlier, such as citric acid, acetic acid, and vinegar, while others are not. Many acids are corrosive and will react with metals. Aqueous solution of acids conduct electricity current because of the ions present in the solution. And when an acid dissolves in water, it reacts with water to form ions, and in a process called ionization. So for example, when a hydrogen chloride is bubbled through and dissolved in water to form ions, the hydrogen ions and the chloride ions separate. Acids are not only present in fruits, they are also present in nature, and here are some examples of acids in nature. The first one is when scorpion sprays a mist of acetic acid from rear of the abdomen in self-defense. The second is limestone caves occur when CO2 dissolves in rainwater to form carbonic acid, making the rain acidic. So the acidic water reacts with limestone and slowly dissolves it, and eventually the rain caves large caverns in regions that have thick layers of limestone. The third example is hydronia flowers produces different color flowers based on acidity of the soil. And the fourth example is when you are bitten by an ant or brush against tiny hairs on a stinging needle plant, you feel a stinging pain, which is the formic of acid. The acid dissolves the ends of nerves in your skin, causing pain. So to name the acid, binary acids are composed of two elements, the hydrogen and a nonmetal. So for example, when a hydrogen chloride is dissolved in water, a binary hydrochloric is formed. So to name a binary acid according to the classical method, first you have to write the root of a nonmetal name, and then second you have to add the prefix hydro to the root name and add the ending IC acid or ic acid to the root name. If the anion name ended in ate, replace it with ic at the end of the name, while if the anion name ended in ite or ite, replace it with ous or ooze at the end of the name, and then add the acid to the end of the name. To identify strong acid and bases, these are strong electrolytes and exist as ions in aqueous solution. Their equilibrium lies far to the right and they will yield a very weak conjugates. And there are types of acids such as the monoprotic having 1 proton to donate, the diprotic having 2 protons to donate, and triprotic having 3 protons to donate, and oxyacid, acidic proton attached to an oxygen, and an organic acid have a carbon atom backbone. While identifying weak acids or bases, these only partially ionize in water. They exist in a solution as a mixture of molecules and component ions. They are weak electrolytes unlike the strong acids or bases, and their equilibrium lies far to the left.
Self-ionization of water is when self-ionization is a reaction. Kw relates to Ka and Kb through this equation where Kw equals Ka times Kb. If Ka or Kb is given, the dissociation constant for the conjugate of acid-base can be calculated. The pH scale is a numerical scale which extends from 0 to 14. pH of 4 is 10 times more than a pH of 3. Here's the equation for measuring pH. And the most accurate is a pH meter, which measures voltage, More electrolyte means higher voltage. Here's also the equation for percent ionization. Acid-base properties of salt solution. Salt solution can be acidic, basic, or neutral. It depends on the ions that produce in hydrolysis general rules. So strong acids and strong bases have weak conjugates. Salt that consists of cations of strong bases and anions of strong acids have no effect on the pH. Group 1 and 2 metals ions exhibit no acid or basic properties. Water will have relatively little acid-base effect. Anions act as bases, and cations act as acids. Acid and bases are Arrhenius theory. Now, what Arabella said earlier, an acid is a substance that when dissolved in water increases the hydrogen ions, and a base is a substance that when dissolved in water increases the hydroxide ions. In a proton transfer reaction, an acid species donates protons, and a base species receives protons. A Bronson-Lowry acid must have a removable proton, and a Bronson-Lowry acid must have pane of unbonded electrons. Conjugate acid-base pair. A conjugate acid-base pair consists of two species in an acid-base reaction, one acid and one base that differ by the loss or gain of protons. Ionization is when acids or bases are added to water, they are ionized. Thank you guys for watching. I hope you liked it. Bye!